Okay, so hi everybody, welcome to my talk. So who am I? I'm Evey. I can be at most big events be found at or in or and around the NOC. And during my work at the NOC, I mostly keep myself busy with the network design of the NOC. So how do we design our network? And at the bigger events, I primarily only do the automation. And that's also the main focus of this talk. To give you a better overview of the automation that we use that we normally cannot fit inside the like 10-15 minute infrastructure review talk that we normally do. And so yeah. Then a big disclaimer. I am the person who is presenting it right now, but by no means this means that anything I am presenting is done 100% by me. There are a few people who I want to specifically shout out, like Moopman, Evey, Welter, AK Ruby, Killer Geek, Craig and Kilobyte, and a bunch of other really awesome creatures who work always really hard at the events at the Internetmanufaktur to make it possible. So yeah, then you know that this is mostly, I am giving you the information, but this is definitely not a thing I all did by myself. So how do we build a network? We collect some switches, and then we collect some more switches. Then we get some optics. Then we collect a bunch of other random crap. Then we do some magic. And then hopefully at the end of the build-up we have a nice green, well, mostly green, nice green dashboard and everything is happy. This is, of course, the short summary. However, a thing a lot of people forget when running a network is you also need services. You need to be able to have DNS, you need to be able to have DHP, you need to be able to have monitoring, and a bunch of other things. This is also a lot of work. I won't cover it in great detail this talk because this is like not my expertise. And it's often forgotten that it actually is really important. For the people who attended 2 congresses ago, you maybe have seen in the infrastructure review talk that we had an oopsie. The flight case, well, this is the new generation flight case. The old generation flight case sadly died in transport. This would have been a big issue. However, everything is in Puppet. It's one big repo. We work on it for every event. So we could just get some new servers, do the Puppet apply. Magic happens. At the big events, this Puppet run is done every 15 minutes, and it fetches all the information that it needs from Netbox and a bunch of other sources. Maybe at some point we will hold a whole other talk, well, the person's responsible for this, hopefully at some point, about how this is all set up. But yeah, it's a flight case, we ship it, we plug it in, and then magically we have all the things we need, and it's amazing. And it's like the unsung hero that makes the NOC possible. Then let's say about, okay, we want to build a network for an event. Like say some congress or camp, what are the requirements that we have? One is that the configuration that we design or generate is not dependent on specific features one vendor has. The vendors that we use at every event differ a lot, although over the past few years it has been a stable pool of vendors. However, we never know what we're going to get. We never know who will be sponsoring us. We never know where we get donations from. So we need to be able to be as vendor agnostic and abstract as possible. Besides that, over the years, a lot of the normal teams, for example, the POC and CERT and radio, they are all moving to doing things with IP and things with Ethernet. So we need to be able to support them in their work, and they can have a bunch of different requirements. And we also need to make sure that our tooling isn't tied to one specific source. So most of this talk will be about Netbox, but our tooling isn't specifically tied to Netbox. We could swap it out for another backend. In previous years, before we switched to Netbox, it was just a bunch of text files, and we are quite flexible with that. But those are like the major like requirements that we have. Then sort of the service portfolio that we are offering to other teams. This is, of course, the internet for the visitors if you plug in a switch. Then we have the site-wide Ethernet and slash to the Wi-Fi if needed. This is, for example, used by the POC for their antennas, for the SIP phones, bunch of other things. If you just need some Ethernet domain, or you want to run your own network and you need to get a server from A to B, we can offer that. Then we have the site-wide routed networks. So that's like internet access, but it's the same domain across the whole event. This is, for example, used for Wi-Fi and any network that needs to have, for example, firewalling or special filtering or any other requirements that a normal device cannot handle. And then over the years, we've also been sort of dibbling ourselves in doing some optical transport for teams. At quite a few events now, there have been, for example, 5G radios from the GSM team, and they, for example, require optical transport from the antennas to their base stations. And last event, for example, the ISDN that was deployed, that also needed SDH transport. So we will then make sure that they have enough fibers available in the building so they can run our things. Or, for example, RFOF, so like radio frequency over fiber, if there's some remote antenna or a team wants to deploy DOCSIS or any weird things, we can probably offer it. So device roles. Our whole network boils down to device roles. We have 3 device roles. We have a router that does routing. We have a distribution switch. Nowadays also does routing, but historically speaking, this has been called a distribution switch. And we have an access switch or dance floor switch, as it's called. Quick going over them. The access switches are the switches that you find on your table. If you're in a hack center, for example. Historically speaking, there was a separate automation suite for the access switches. And they were set up in a way that we put them on the table, we plug them in, and we don't touch them anymore. During 35C3, we sort of merged the 2 automation suites into one to make it easier for ourselves and also to learn from each other's experiences. And historically speaking, the access switch was just anything we could get our hands off. It was HP, Brocade, Arista, Juniper, anything that somebody had a pallet laying around that we could get. Over the last years, we have been sourcing this from Event Infra. This is a non-profit based in the Netherlands that maintains network equipment for other non-profit and community-run events. And we ship, or Event Infra ships the equipment throughout of Europe to a bunch of events, and also a lot of the chaos events that don't have their own hardware supply get it from Event Infra. Then the distribution switches, they are a lot more, modular, in the sense that every time you plug in an access switch into a distribution switch, it needs to get a new configuration. Normally, this is relatively modern hardware that we get from any of the major vendors that borrows it to us. And the original automation that, what I'm mostly going to talk about, was targeted at these switches. And we try to have the same distribution switch model for the whole event, just to make our lives easier. And given network equipment isn't well known to be bug-free, it's really nice to have like only one set of bugs you have to worry about, and not 25. And then the routers, also frequent config changes because they host all the gateways normally, does the central routing, does firewalling also, and these are like big boxes, so this is like a somewhat older picture. Nowadays they're a lot smaller, but it's a picture from Leipzig, for example, where we had all the switches on the tables, for example, in the big halls. For people who were there and remember, were like terminated on one big box because it was quite simple. One box, lots of ports, not a lot of config fiddling, and relatively straightforward. So then, this is in the end what we do, Netbox, and anybody who uses Netbox will just use Netbox, and everything else is abstracted away for them. And the people who do the automation and all the other frickling, they have to worry about the magic under the hood. But for all the people in the other teams and also in the NOC, it's just clicking in Netbox and magic happens. So Netbox is a really powerful tool, but there are also a few issues with Netbox that you can get lost in it. So a really important rule is don't try to model everything you do in reality in Netbox, because then you will spend days clicking. And we don't have the time for that. Just make sure you put enough things in that box that your automation can solve it. And don't worry about the rest. And a really important thing is don't try to duplicate data. So if you have a thing in Netbox, make sure it's only in Netbox and not in 25 other places. Otherwise, if you change something there, then you also change it there. It's a mess. Another thing really important, Netbox supports scripts or custom forms. They're amazing. We use them a lot. We'll go into detail later. But this allows you to make custom web UIs that other teams can use, so they don't actually need to understand how Netbox internally works, and they only have to click on one page instead of 25 or something. So how does a switch in our Netbox look like? So this is a switch. This was deployed in room 02201, no clue what it was, but it doesn't really matter. A few important things. The device type we use, the serial number we use so we know which switch it is, the primary IP address we use so we know we can reach it, the role is really important so we know what kind of configuration we need to apply to, and the default access VLAN, this is a custom field that we use. This uses our automation, so this means if there's no configuration on the switch, make sure that all ports on the switch are in this VLAN. And then if you look, for example, at the interfaces of the switch, this is like at the end of the event, you see that most ports don't have any config, so they will be in the default VLAN. And then we have the uplink port, that's like tagged all and also marked as the uplink. That's also really important for automation. Then we have the VLAN interface with the management IP address. And we see, for example, that an access point was connected on port 0, and that port 1 got used by the POC for something. Now, this is all fun, but how do switches in the end know what VLAN they need to put on the ports? Because we don't want to put this in Netbox, because if you enable it on, for example, you have 10 switches all chained to each other, you configure the last switch in the chain, you need to configure everything upstream. Too much time. So our automation does makes a big tree or a big graph from the whole network, and will then walk the tree. So this is a small example. We have, for example, a switch with default VLAN 1073, JL009. That's like a distribution switch, and then a few other distribution switches that don't really matter. So let's say if we hook up the distribution switch, JL009, what automation knows, it's connected to 2 other distribution switches, so it will automatically apply the backbone configuration on those ports. And then if we, for example, hook up the switch to the distribution switch, then it automatically knows it needs to put VLAN 173 or 1073 and VLAN 10, and that's the management VLAN in this case, on that port so we can reach the switch. Then, for example, we plug in an AP and we plug in a DECT antenna, for example. Then in the next iteration, it will add the DECT VLAN also on the port, so the switch will get the DECT VLAN and the DECT antenna can reach the other DECT antennas. The IPs are normally placed in the default VLAN, so no changes are required there. So then we do this tree walking and we get a bunch of information, and we need to sort of feed this information to the templates that we use to generate the configuration, because the configuration of a switch is just a big text file with a lot of statements that tell the switch what it has to do. So this is an example, list of variables that we feed into our templating engine. The important parts are the access ifs. So this is all the interfaces that are special, and they tell us, for example, which VLANs need to be on the port, if there's like a special speed that it needs to be set to. Then the core ifs are the interfaces going to the core, to the backbone, so we know that they have to have a special configuration too. And lag ifs are, you can put multiple interfaces together on a network switch, so they are bundled. And the lag ifs are like, in this case, XE020 and XE021 form a lag together, and the lag is named I0. So this means just make sure that you put those ports together. Then a few other things. The VLANs, the untagged VLANs, and the access ifs. The access VLANs are all the VLANs that need to live on the devices. And you would think, okay, why do we have the VLANs here and the VLANs in the access interfaces? This is because some switches require you to put the VLAN on the port, and some other vendors require you to put the port on the VLAN. And by doing the mapping already in our automation, makes the writing of the templates a lot easier. Last of all, we have the static things. This is the event config. This is a JSON file that we write before the event. This contains, like, for example, TCP servers, the IP addresses we use, SMTP details, and other things that will never change. For example, the admin password is also in there. It's not here listed, so. And for example, also prefixes. This is, for example, the IP addresses that are per VLAN in use. Users are all the users that need to have a login on the switch. And the VLANs are all the VLANs that are in use at the event. But for brevity use, I have left those out for now, because otherwise this would have been like a few thousand lines. So not sure if anybody here uses Netbox often, but PyNetbox is the Python API that you use to talk to Netbox. And the Netbox API is, well, as you can see here, somewhat slow. An API call takes approximately half a second. We need to do 2 API calls for every switch. So this means that we need 1 second per switch. However, for every switch, we also need to, if it's connected to other switches, we need to do those 2 API calls again. So this means that if you have, for example, a core router and you're using PyNetbox normally, the config generation can take 15 minutes or half an hour. Of course, that's not really acceptable, because if we deploy every 15 minutes or like every 10 minutes, we can't really wait. Luckily, caching exists. So what do? Python magic, if you don't understand this, no worries. Try to explain it to some degree. Is with get item and get attribute, you can override the default Python behavior. So what do? Is if you would normally access an element in the, so for example, if you would normally access the, so if you would normally access like dkim.devices, we will override that with these 2 items, and we make sure that you call our internal dictionary with where we are. And then this is the magic that makes sure that there is a dictionary, internal dictionary for every item that you request. So there will be a dictionary for example, all devices and all interfaces. And then under the hood, under the hood, we have a small like a Python dictionary that is backed by DBM. This is like the default thing that's in the Python standard library to store items on disks. And per item that we get from PyNetbox, we store when we got it, the TS, the time, and the data. And there are 2 different modes that we use internally. One is like we open the database once, read it all in memory, or every time you request an item, you open the dictionary, so we can actually update the dictionary. And then we also have to update it. So every 15 minutes in our case, for example, we will just get all items from Netbox and just update them. Or like check if they're in the cache. If they have expired, then we fetch it again. If not, we will keep it that way. Now, there's this like joke online, or like this meme that like there are 2 hardest problems in computer science: cache validation, naming things, and off-by-1 errors. Cache validation is surprisingly hard. And this is an example why it's hard. So this is an interface that you get out of Netbox. This is like interface GE010. It is connected with a cable, also in Netbox, to device SW384. So we store this whole blob in our cache. But what happens, for example, if we rename this device, we also need to update the interface. Or if we rename the interface, we also need to update this thing. If we disconnect the cable, we need to update both interfaces and both devices. And there are like tons of edge cases in there too, that as soon as you change one small thing, you need to suddenly update a lot of things. Yeah, so Luckily, Netbox has a changelog. The changelog of Netbox will give you every change that happens in the database, and we monitor this. And for every change in the Netbox, there's a changelog item. We read the changelog item and just invalidate all the objects that get touched by this changelog. However, Netbox changes a lot, continuously. What's linked where is not documented as far as I know. So every hour or something, we just delete everything and fetch everything again. Not ideal, but it works for us at least. Then, okay, what is in a changelog? This is a device that got changed. And it also holds the pre-change and post-change data. Then you would think, oh, this is great. We can just take the post-change data and store that in our cache. However, the post-change data is a summarized form that's not the same that you get from the API. So sadly enough, we still have to fully invalidate this. And we cannot just take the post-change data. However, having the pre-change and post-change data is actually quite nice because we at least can figure out what changed and use this to hopefully invalidate the right object. Hopefully. This now has been running since a bunch of years at Congress and also at camp and at the Dutch events and also at a few other events, and it has been working good enough. However, it's still not really like plug and play. The nice thing is though, it is mostly a drop-in replacement, so you can just install this Python package that we publish and it behaves like the normal PyNetbox package. So yeah, then of course, if we have all the information that we want, we need to make a configuration out of this. And for this we use Jinja 2. This is a quite popular Python templating library. And what's really nice about the Jinja 2 specifically is that you can extend other templates. So you can create a base template, and then you can say, okay, I'm extending the template, and then you can override specific subsections of the previous template. So you can make it more and more and more specific. And we use this a lot. Because, for example, we have 10 different kinds of Juniper devices that all require small changes. And we, for example, have multiple device roles. But they're all Juniper, for example, in the end in this case. So we need to make sure that we don't like duplicate things. This is then, for example, the tree that you get from if you take the template for a Juniper QFX 5120. This is a Juniper switch. This is a distribution switch in our case, so it extends the distribution EVPN template. This includes a bunch of other templates. And then the Juniper switch base, that should have been a different file name, but doesn't really matter. And then the Juniper switch base also includes a bunch of things. And then, for example, if we have an access switch that would extend the template Junos ELS. And this means that we can really quickly add a new device type or a new device class or anything by just extending the device that is most similar to what the devices that we have. Now, how does this look under the hood? For the people who are interested in it, at least. So this is, for example, the switch base template. And that's like we include the underscore J system. That's mostly just to make this file readable for us. Otherwise, it would have been like 1,000 lines. So a lot of the similar items get moved to separate files. And then we have these blocks. And blocks can be overwritten if you extend them. So if you extend this template, you can say, okay, I would just say block name, and then what you put there will be replaced in this template. And for example, for groups, we have a block. For interfaces, we have a block, etc., etc., etc. And then, for example, this is then the template Junos ELS. The first part is really important. This is the first line that is above every template that gets used. This is our hint rule. And with this hint rule, our automation can figure out if it gets a device from Netbox, which template does it actually need to use. So this means that it's a switch, and if the device type matches this regular expression, so it's a Juniper EX2300 or 3400, apply this template. Well, it extends the Juniper switch, the template Juniper switch base that I just showed. And then here we have the top interfaces block that's now filled in with the generation of the interfaces. This is then abbreviated, but you get the idea. And this allows us to really quickly add a lot of more things. And it's just amazing to do. So zero-touch provisioning, or zero-touch provisioning, as a lot of people in the industry call it. Before an event, we normally have a few hundred devices that we get fresh from the manufacturer or fresh from a storage, that we need to put something on there that we can use it in the field. It doesn't have to be the exact config, but it has to be something that we can log into it and that our automation can talk to it. You would hope, famous last words, that most vendors would make sure that their zero-touch provisioning is the same for all their platforms. Not the case. Juniper is specifically bad in this. It got a lot better with the modern versions, but given we have a lot of old equipment, it differs per platform, per software version. Sometimes you need a MAC address, sometimes you need a serial number, sometimes you need both, sometimes you need to... a mess. Arista is really nice in that case though. It just, give me a shell script, I will run it, no worries, everything is fine. The only thing you need to do is, older Arista ship with Python 2, newer with Python 3, so you need to make sure that you, like, in your shell script, use the right Python version, but that's all fine. So, over the years, we have tried a bunch of things. Usually it was, we will just frickle it when we're there. However, this doesn't really scale. And, well, it's quite frickled, and we always forget to save it or put it in a Git repo, and then after like 12 months, we're like, okay, how do we do this again? Then we migrated to ICDHP with locally generated base configurations. Cool, worked fine, still a lot of frickling. Until recently, aka sort of last year, we used ICDHP, and then the switches fetch the configs directly from our config generation. So they need internet for that, but that's fine. And the fourth generation that we first deployed at Y, and also at, no, I think it's at Y, yes, for the first time in a large deployment, is Cthulhu. This is our new fancy technology-based, Rust-written, all the buzzwords, serial-based wiping and provisioning utility. And it's amazing. So ICDHP magic. In ICDHP, you can rewrite a response based on the parameters you get in the request. So this means that we get the host name that the switch is sending us and the vendor class identifier, and we can stitch it together and put it in the config file name as the DHCP response and send in the Slack file. I will go into detail what Slack is. It's, well, a thing. Kea could until recently not do this, and until recently I mean like quite a while ago, but distributions often ship really old chaos. You can also rewrite, if you load the libdhp flex option hook, then you can all do the same magic in Kea 2, given ICDHP is deprecated. Oh, I don't mention Slack anymore. Well, Slack, XML style sheets, you don't want to touch it. Cthulhu. For the people who know expect, this is a thing in your console that you can be like, if you see this name, or if you see this regex, if you match this regex, please type in these commands. So you can like automate shell scripting. Over the years, given any equipment that we use at events is not allowed to leave the event with configuration still on there because there's sensitive information on there. And we don't really care about our configs, but we do care about MAC addresses of visitors, IP addresses that got used for things, and other information that can identify visitors that were at our event. So we need to wipe everything. This was done for quite a while manually, so we get the equipment back into the NOC, wipe it, stash it away, takes a while. Over the years, we have been writing some expect scripts for this, also still quite finicky. And then a few people on NOC, or like one person mostly, got fed up with this and was like, I will fix this, and wrote this magical tool. It's called Cthulhu. It's Rust-based, or within Rust. It's expect, but on steroids. This is like the web interface, for example, where we can see per port that a switch is connected to, what the state of it is, which step of the process it's running into, and if it's done, or if it's like, if there's a weird error and we need to restart it. Then Cthulhu uses HCL, or some other people, the Terraform language to describe the state engines. This is a small example. You say what kind of flow you want to run, and in what flow, or what graph it needs to run first. In this case, this is the Arista provision flow, and it needs to run the Arista wipe steps first. Then you have a state. In this case, it's called Arista provision bash 1, and a state can have one or more transitions. And if a transition happens based on a trigger, in this case, if the string matches what we're seeing here, it will do an action, aka it will send line, and in the line is then the information it will send, and then it will go to the next stage. In this case, it's then provision Arista bash 2. These files are huge, but it's really nice because we only have to write them once, and we can like add things for like weird edge cases, for example, or what happens if a flash chip breaks on a switch? Can we detect this? Versions of switches that we need to like do some manual flickering in, all supported. And it also generates reporting for us. So we have extensive reports per switch, what happened, how it happened, did it get properly wiped, did it properly get provisioned, etc., etc., etc. Then how does this look like in real life? One big cable mess, as you can see. There's an Ethernet cable on every switch, so it can fetch the configs. Serial cable that goes to Cthulhu. And there is this PCB here. And you're wondering, why is there this custom PCB with also a lot of cables in there? This PCB drives these LEDs that you can see here. These LEDs are in line with the serial port, and the status information that you saw here, so the colors here, match the LEDs in line in the serial. So if it's green, we know we're done, we can unplug it. If it's red, we need to flicker it manually. If it's like purple, it's still doing things. So we can practically just, without looking at anything, just wipe and provision switches. And this speeds up everything a lot. And then you're wondering, okay, how does the other interface look like? If you click on the switch, then you see this. On top, you have the serial output of the switch, so you can read along. You see what the state of it is. Well, this is like a thing that happened a few weeks ago, but and you see the state history. So this is all the steps that it went through. And device information. So Cthulhu can extract relevant information in this flowchart, and this gets saved into the device information. So the vendor, the model, the serial number, whatever we want to add, we can add it here. And this is quite handy because, for example, we need, of course, the serial number to look up the configuration in Netbox. And this information is again also available in the steps to do that. So we now have a configuration on the devices with Cthulhu. We're going to deploy them in the field. For anybody who ever used Netbox knows that clicking, like even putting a switch somewhere and hooking it up in Netbox is exhausting. You need like 25 different forms you need to fill in. It's a mess. And especially, for example, in the CCH, the patch rooms are quite far away from where the switches are. And this is also quite a common problem in other buildings. So we want to be able to separate the tasks of having angels plug things in and having people from the NOC or trained angels patching things in the patch room. Luckily, Netbox scripts exist, so we hacked something together. I hope this is visible. Yes, good. This is the patching form. I think. No, this is the, you plug something in for. So you say the VLAN, so what network it needs to be on. For example, you have an RFP, you're the POC, you want to plug it in somewhere, you hang it up, you plug it in, and you say patch panel. That's the room where you want to connect it in, that's written on the patch panel. Then you say the patch port, you type in the name that's there, and you can put endpoint name for extra information. And then it gets stored in Netbox and you can continue and not worry about this. This is the same thing, but this is, for example, if we have an AP that is in Netbox that we want to deploy somewhere, we say, okay, we plug in, we put an access device, an AP somewhere in the port, and then it also puts the AP in that location. So it's just a bit more information for devices that we have ourselves. And then, okay, you are the angel that will patch. You open this form, you select the location, you're in there, and then the front port will show all patches that still need to be made. So you click on there, you plug in the cable, you select in which device and in which port you have plugged it in, you click on run, and it will automatically click everything in that box that everything is okay. The cable will be connected, the VLAN will be configured, all fine, nothing to worry about. For example, how does this look like? This is, for example, an RFP that got deployed somewhere, and it will then have a cable in Netbox done by the script with a cable desired VLAN, and the cable desired VLAN is the information that the automation will use then to apply the VLAN on the port on the switch. And this is not a thing then you have to click. Because if you wouldn't use those forms, you would be spending like 5 minutes per device clicking in that box. Because you would need to create the cable, connect the cable, configure the VLAN, configure the port, put the device in the right location, change the state of the device. Yeah, it's not that nice. Okay, then snafu. Another custom-written tool last 2 congresses ago, or last congress. This is our automation status monitoring. So what it does is it groups the switches per device type and gives us information when a switch got updated last. If something happened, we can pause switches and we can give comments why we are pausing it. For example, you're debugging something, you put in pause and you say reason, like down here, I'm debugging it, come talk to me if you have any questions. And there is, of course, the big red emergency button, because automation is generally just pointing a big gun at yourself. Because automation is really nice if it works. If it not work, it blows everything up. And if, for example, somebody changes the template and suddenly everything fails, we know, okay, we need to fix it again. So our config automation on the switches is pull-based. This means that a lot of people, when they hear about automation and configuration things, they push configurations. So you have your automation suite that will push config to a switch. This requires a few things. Well, you need to know which switches are actually deployed, where they are, if they are reachable already, and a lot of other things. You can, of course, try to push to all the switches you have, but then at early build-up, a lot of things fail, and you need to have a lot of things in place to make sure it works. With snafu, specifically, how it's designed, and also how we have been doing it before this dashboard exists, is pull-based. So there is a small cron job running on every switch. And what the cron job will do is it will start up and it will check if it actually is needed. Because if you wipe a switch, fun fact, cron jobs on Juniper stay. And you don't want, if you switch the switches to other events, that they will try to fetch configs from our automation. So it will be like, okay, am I actually at the event that I'm needed? If not, I will uninstall myself and you won't hear anything from me again. Then it will ask snafu, like, hey, are we actually active? Like, is the emergency stop pressed? Am I paused? Well, snafu will say, for example, no, all good. Switch will get the config from IMF-CFG. Config gets stored. The switch will report to snafu, I have successfully fetched the config. Then we will check, okay, did we actually change the config? If not, we'll say, oh, good, and we stop. If it actually has changed, we will validate the config. So we will try to apply it, check if there are any errors. If there are errors, we will report the errors and stop. If there are no errors, all good, we apply it. And then the last step, did we accidentally disconnect ourselves? So every switch will try, after it has applied the config, to reach the management gateway. So can I still reach the internet? Am I still reachable for the NOC? If this is the case, all good, we didn't mess up completely, and we can fetch a new config later. If we cannot reach the management gateway anymore, something terribly has happened, so we roll back the config to the previous well-known state and report that it's all broken. This has been working for us. So we designed this at Camp 2019, if our history is correct. And it has been like a great success, given we can just tell other teams and also ourselves, just click a netbox, and within 15 minutes, because that's the interval that this script runs at, the configuration will be applied. If not, come to us. And there's a lot less ticketing, talking to people. It just works out of the box, and it is amazing. Then, okay, how do we do this all in like one big timeline? So we figure out what we need. Where will be the event? How many switches do we need? How many APs do we need? Where do we get the stuff from? What kind of design do we want? What are the requirements? Then we throw everything in that box with the help of the device type library. Amazing thing. It's like a community database of all different switches that exist, so you don't need to manually create the device types. I love it. It's been helpful. And then we have some custom tooling in that box to like set an IP address to a switch, configure the uplink port that's already uplink, and a few other small things. And assign the default access VLANs, create the IP addresses, create the prefixes, like the usual stuff. Then we set up IMS-CFG. This is the automation tool, so we configure the event JSON with the things we need, the IP addresses, the users. We configure ctd-site.py. This still needs to be ported to the event config.json, but work in progress. This holds things like IP prefix automation. For example, if you have a v4 address on a prefix, this will auto-generate v6, and a bunch of other small things. Configure the SSH key, so who will help out this event and who needs access, and then generate some example configs and check if it actually works. Then we stage all the devices, aka Cthulhu and chill. For example, at Y, we did all the devices in like 2 or 3 hours, and normally this took like at least a day. So it's been a huge time save. We deploy the equipment and wire it all up. Then we wait for snafu to do its thing and the automation, and hopefully we didn't fuck up. While we're doing this, and we do all the fancy IT things, we also really love Kanban boards. If you run into an issue, write it on a post-it note, throw it on the wall, and then hopefully somebody will pick it up. So having some physical tracking of what you need to do, how it's going, really makes it possible to distribute tasks across people and prevents having a single point of failure. And lately, we also, for example, have had people just dedicated to managing this board and making sure tasks get done and asking how it's going. And that has sped up our deployment a lot. Then, of course, the rest of the event, it's just clicking in that box and flickering templates and having fun. And then teardown. Yes, also a mess to do it properly. System we introduced a few years ago, can recommend. We just collect everything, bring it to the NOC, and then not sure if it's well readable on from the room, but there are like different drop-off points for everything. So you just grab everything, put it in a big container, walk to the NOC, sort it on the tables, and then you can, for example, see here, and a bunch more other tables that will then, for example, sort it all out. So fibers will get cleaned and bundled, power cables will get checked and also bundled, and I'll put back into storage for the next event. So a few takeaways if you ever want to do your own event and you do the network there. Don't underestimate having working DHCP and DNS. We had multiple events where we were like, oh, this won't be a problem. We'll just YOLO it when we're there on site, and then it will, it delays everything. Don't overcomplicate things. you need to be able to understand it, explain it to people, and for example, we have been using ICDGP since last year. We recently switched to KEA, even though it's been deprecated for a long time because we know it works, it's stable, and with a lot of things, just pick a solution that has been well trusted and works. Of course, the hot new thing is fun, but play with that during the event and keep like the stable old thing running. And also a lot of people underestimate walking around to fix switches if you fucked up your config. Takes a long time. We had this a few times. It's not fun. Then you suddenly are a day late with your build-up because you need to walk to all switches, plug a serial port in, type some things in. Not nice. Make sure things work before they go out. And as a, for example, solution for this in the future, we are working, for example, on a portable Cthulhu that we can just take with us, plug in a switch, and it will auto reprovision the switch with the right configuration. Then where I can find everything that I've just talked about, also important. On my own GitHub, you can find the IMF CFG, the templates, and a bunch of other support tooling, and for example, the cache netbox. And Cthulhu, that's our Rust-based, serial-based configuration utility, you can find on the event infra GitHub.org. I will also send the tweet out, and hopefully, if this works, update the talk description with the exact links to this. And that was it. Are there any questions? Oh, do we have a microphone for this somewhere? The NOC is the Network Operating Center. That's the group of people who make sure there's internet at your event. Is it on?
It's on? Yeah. Yeah, okay. One question regarding zero-touch provisioning. Do you use zero-touch provisioning anymore, or is everything now in Cthulhu?
So this is still a bit up for debate. At why we did everything in Cthulhu, mostly because if you already have a serial cable attached to your switch anyway, because you need to do things with it, just pushing the config in there makes a lot of sense. Footnote though, the config will get fetched over Ethernet, not over the serial port, because that takes way too slow. So it's the serial port is just a command. Please download it from the configuration server. On Juniper, this will be a load override, and a URL. On Arista, this will be something else. But yeah, we disable zero-touch provisioning first, and then we fetch the config.
Another question, if nobody else wants to ask one. You need some level of smartness in your switches to be able to support them fetching their own config. That's not really something that's supported by most vendors, or how do you do that?
We haven't run into a vendor yet that doesn't support this.
Okay.
So, of course, really old Procures, HP Procures, for example, doesn't support this, but most vendors will have some event or time-based execution of scripts in their custom language, where they often allow you to fetch a file and override a config. Most events recently we have been running is Juniper and Arista, for example, and they all support this. If we would ever run into a case where this isn't the case, that we have a switch that doesn't support this, we could, for example, run an interposer that will do like that, the pull to push translation for that specific switch vendor. That would be an option, yes. And if that's it, thank you for coming to my talk. And if there are any more questions, I will be at the event around to talk about this or give insights if people want to. And have a nice event.